welcome back. Today we're going to show you our KOE universal tool cutter grinder, and along with that our Hibco two-way cam relieving fixture. Now this machine on its own is an incredibly universal machine, as in its name, and it's just amazing the things you can do with it. You may have seen previous videos where we did some radius grinding on it, internal and external, and there's just a whole mountain of things you can do with a machine like this. Now this guy here is interesting because you can infinitely adjust its travel both radially and axially, and you can dial it in for just a huge range of different things. So I've got a few examples here of different cutting tools that you can sharpen with this cam relieving fixture. And if we zoom in a little bit, over here we've got a single flute countersink that can be sharpened, and this is actually our single flute cam that goes into the cam relieving fixture for different numbers of flutes. A two flute center drill along with its cam, some 3 flute countersinks along with the 3 flute cam, and you can see it's got 3 distinct high spots, and you'll see more of why that is later in this video. And then here's a tap, and this is what we're going to start by sharpening today, and it's 4 fluted, and I've got the 4 fluted cam here. So we're going to get this in the Hibco fixture and set this thing up. So I'm putting in the 4 fluted cam here, and I've got all the travels locked out. That allows me to pull this roller, the cam follower actually, away, and then I can slip this in here. It's just a little snug. I'm going to give it a little tap here. There we go. So this cam gets held in place with this piece that is part of the drive mechanism with this belt, and also our collet tightening piece goes into that and snugs our collet down. Just gonna snug that in there. This is actually, I guess you'd call this a drawbar. This is a drawbar for our collet. So all these cams, they're timed with a keyway here that you can see, and that's the reason for that is so that every time you put the cam on, it's doing the same action at the same point of rotation. And if you can see just right here, this is a part of the machine that rotates, and there's a line stamped in there, and that's for setting the height of your tool as you're setting it up. So basically, I'm on that line, that's where I want to start, and I want to be halfway, like I want to be halfway between the end of this flute and the beginning of this flute. So I've got that about where I want it there now, and I'm going to snug that down. So right now, I've got all of my relieving features locked out on this machine. So basically what I'm saying there is this spindle is just spinning around. So you can see if we dial on the shank of this tap here, we're coming to 0, close enough. And basically, so that shows you that this is spinning just around. Now, the way relief works on a tap, for anyone who isn't aware, is it doesn't just go around. As you come away from the cutting edge, the dial is going to read minus. As you come towards the cutting edge, the dial reads plus. And what we're measuring there is the amount of relief that is actually behind this cutting edge on this tap. So it's this lead-in area of the tap that we're going to be grinding on and sharpening, and that's going to give a fresh cutting edge. This tap actually isn't particularly dull, but this is what we wanted to do today. This is what we wanted to share with you guys. So the next thing I'm going to do, I've already made my spindle the same height as the center line of the Hibco fixture, so that's done. I've got my spindle dialed in true to the table, so that's done. I've already changed my drive pulleys over to the proper configuration for the aluminum oxide wheel that we're going to be using today. So the next thing I want to do is adjust this fixture and get this surface running true to the center line of the table so that we pick it up exactly. There, that's pretty good. These two dials here are part of this fixture. This one shows you the radial travel as it goes around, and this one shows you the axial travel. And those are basically infinitely adjustable, and I'll show you in a minute what I mean by that. But for now, I'm going to disengage the lockout on the camming action. That's the radial lockout. Can't see this over here, but there's also an axial lockout. So I've got the cams both adjusted fairly aggressively right now, and I think, especially if you look in here, for example, as I spin this around, you can see that it's traveling. And these dials will tell you how much it's traveling. You can see it's traveling a huge amount axially and quite a small amount radially. So what we need to do is get both of these matching the existing relief that's ground into this tool. So this knob adjusts the axial travel for the axial relief. And right now I've got an awful lot of relief here. It's like 57th thou or something. So and that's way too much for what we're doing. So what I'm going to do is I'm just going to turn this in the minus direction. And now you see as I do that, that travel's being reduced pretty significantly. We're at about 25 thou now, and about 20 thou. So that's where I'm going to leave that set at about 20 thou per stroke. This knob here adjusts the radial travel of the fixture, and we're reading that here. Right now we're at about 25 thou. I know it needs to be less than that, but what we're going to do is we're going to adjust this while we're indicating off of this surface at center height on this side, and we're going to get that running 0. And when this test dial runs 0 on that surface, that'll mean we've exactly matched the relief that's ground into this. And then we can double check that our angle this way is correct. So we should be able to go around and around and back and forth and have this dial read 0 the whole time. Can you see right there? Yeah. So now as we rotate our cutting edge up to center, we see a reading on our dial, and we want that to not move throughout this rotation. And you can see it's doing some stuff in there. It's coming plus, which means I still have too much radial relief set. So I'm going to go minus a little there. Okay, so it's all adjusted up now. You can see as I rotate up, the cutting edge comes, we come up to our 0. As we rotate through, we stay awful darn close to our 0. And also, as we move longitudinally, we stay at our 0. So it's ready to go. So this thing's good to go. What I want to do now, I just threw this grinding wheel on. It's an aluminum oxide grinding wheel, and it's not running true currently. So I'm going to give it a little lick with my diamond dresser, get it running true. That'll give us a much nicer surface finish on the surface of the tap that we're grinding on. So here's our tap. It's nice and sharp. I don't know if you can see that. Probably couldn't see that. But the surface finish isn't great. I did a rough dressing on my wheel just so we could take a little material off of here. Now I'm going to do a finish dressing on my wheel so that we can really shine this puppy up. I'm also going to slow down the rotation. That'll help improve the finish as well. Okay, that's done. So now, if you can see, we've got a really nice fine finish on there. So there's our tap done. Now we're going to set up and we're going to do a single flute countersink. You can see this is actually dull. There's a nick out of it there. This actually does need love, so we're going to do that. I have a couple of 3 flute countersink, same thing. You can see this cutting edge is really rough, so we're going to dull them up and make them usable again. Since we have this set up anyways, it's quick and easy just to make these small adjustments to grind these different tools. Ha! Metric.
Yeah.
Bastards. You got metric. We can do this.
Do you have to climb up there?
Maybe.
This is what I say when I climb up there. There's our stash.
A little bit rusty. It's been sitting up there for a while, so I'm just giving it a quick wire wheel with a real fine wire wheel. So before we switch from the 4 flute setup for our tap that we ground over to our single flute cam, I just want you guys to have a look at this dial so you kind of understand how the grinds differ between the different numbers of flutes. So this comes in, and then back out real quick. And in, back out real quick. And that's so that when it's coming in, it's creating relief, and then it comes back out quick to reset for the next tooth. And then it comes out, resets for the next tooth. So that's what you're seeing there. So now we're going to put the single flute cam in there, and we'll look at how that's different. This cam, the way it works, is when you're grinding at the cutting edge, it comes in, and then stops and just goes flat. And then it pops back out, and then comes in, and it goes flat again. So a couple little adjustments we need to make to switch over. The angle on this countersink is, well, it's an 82-degree countersink. It's much steeper than the tap. So we're going to have to rotate this around, and so that it's running, that the edge we're working on is running true to the traverse of the table. So whoever manufactured this countersink has a slightly different cam setup than I do. So like with the tap, if you noticed, it started cutting on the whole surface all at the same time because we were able to dial it in that way. And here, we're not going to be able to see that. It's still going to cut fine. It's just that whoever built this had a cam that continued the cam action throughout the whole rotation of the thing, and ours isn't going to end up being like that. So we're all dialed in this way. So basically, what that means is, in this direction, this whole piece is going to clean up at the same time because we're dialed in this way. But when it comes to the clearance behind the cutting edge, it's going to be doing some slightly different things than what you see here now. So that chip is all gone. Got a nice fresh cutting edge again, and nice decent surface finish there. And you can see, as I explained, we're not cleaned up all the way. But what we'll do is we'll make this fixture run true now. We'll run the dial on this, and you'll see how there's relief behind the cutting edge.
Because it's your favorite dial.
I tell you. My advice is buy cheap hammers, not cheap dial indicators.
Maybe I'll splurge at Christmas or your birthday.
Get me a Mitutoyo or something nice like that.
Ah, there you go.
Here we are at our cutting edge, and as we pass it, you can see the dial's going minus. That's the clearance. Now it stopped moving. That's the end of the clearance. Now it's just round. And when we get into the section that didn't clean up, you can see that clearance just keeps on going. So they had a very different cam setup than I do. So here it is out of the machine. Nice crisp cutting edge, no chip in there, and a nice surface finish throughout our relief zone, and then just the tail end of this drops off. Setting it up for a right hand tool. These cams are reversible. You can sharpen both right hand and left hand cutting tools on this. So here's that 3-flute countersink again, and you can really see the damage to this cutting edge. So we're going to freshen that up. So that's good. We're dialing 0 across the cutting edge there, so I'm locking in that angle. So with this countersink, it was sharpened with exactly the same type of cam that I have, and so this entire surface is going to clean up pretty much simultaneously. It runs out maybe a thou or something. I don't know if that's, could be anything. Could have been previously ground. I don't know. Thou, I'm not worried about a thou. It's still going to countersink just fine. This is my longitudinal handle. This is what allows me to pass by the grinding wheel like this. And this is my cross feed handle that lets me feed the workpiece further into the wheel.
Oh, it's nice and shiny. Is she all cleaned up?
Nah, I can still feel some nicks. I'm going to go a little more. Nice crisp cutting edge on there. That guy's done. So we can call this sort of a before. I think if I rotate this, you could probably see some damage on that leading edge, on the cutting edge. And then we'll call this the after. We've got a super nice finish there, and the actual cutting edge itself, for the most part, is mint. You know, up here there's some damage, really deep, way up high. I didn't worry about that. I just wanted to get the most of the thing usable. And I'm super happy with that finish. Don't know how well that's showing up on the camera, but
Shiny.
okay. So that guy's done. Well, that's it for today's video, guys. Hope you enjoyed. Maybe learned something or saw something you haven't seen before. I know we had a lot of fun making this video, so hope you enjoyed watching it.
And if you did, please like, share, and subscribe.